Hello there, and welcome back to our outdoor lab. Now for today's experiment, I'm going to be demonstrating a double displacement reaction using potassium iodide and lead nitrate. Now for our first obvious disclaimer, lead and all other compounds containing lead are extremely toxic. Always wear gloves when handling the lead nitrate and the lead 2 iodide, precipitate formed in this reaction. Lead nitrate is also a strong oxidizer, so don't go mixing it with other chemicals that can react strongly with it. Now for this experiment, we're going to need 1 gram samples of both potassium iodide and lead nitrate. I originally used 2 grams of each, but however, like how I always do these things, I always put in way too much. So this later on caused a problem with the later demonstration I wanted to show. So yeah, like I said, there was too much precipitate to fully dissolve into the solvent. So this solution became saturated. Basically, I'll be explaining this a little bit later in detailed form. You'll start to notice as we dissolve the lead nitrate into the water, the solution becomes cloudy. Now this is due to a process known as hydrolysis. Now I'm going to show you this process in a minute. The hydrolysis is going to really mess up our reaction. So in order to fix this, we're going to have to add a bit of dilute acetic acid, or basically just vinegar. Now once it becomes clear, we're ready to dissolve our potassium iodide into the other flask. Now I used 200 milliliters in both flasks. I later added water in, so if it seems small at first, don't get confused. Now let me just brief you a bit on the chemistry of this apparatus. When we mix the potassium iodide solution with the lead nitrate solution, a double displacement reaction will occur. In this case, the potassium ion will pair up with the nitrate ion to form potassium nitrate. The lead ion will pair up with the iodide to form lead 2 iodide. In a double displacement reaction, one of the products formed is a type of solid, insoluble material known as a precipitate. The lead 2 iodide formed does not dissolve in water. Therefore, it forms as a bright yellow precipitate. Now if you're afraid you'll miss this reaction, trust me, you're not going to, because the color is way too bright, and it's just so amazing that you'll honestly just be surprised when you see it. Now that they've both dissolved, I'm going to mix both of them in a slightly larger Erlenmeyer flask on top of my hot plate / magnetic stir. Now I'm going to put the potassium iodide mixture in first, because this is usually how I do it, and then I add in the lead nitrate the second time, because it tends to get everywhere once they mix together, and it gets very hard to take the lead off of the flask, so this just makes it a bit easier for me. And now we're going to see what happens. Now we add it in, and it's bright yellow. It looks really disgusting, but it's really cool to look at. You have to admit that. You know I have to be right with that. Just look at it. It's so interesting. It really is. Now for this part of the experiment, I'm going to do a time lapse because it takes quite a bit of time to do. And frankly, I don't want to bore you with 20 minutes of me heating and stirring the solution. You could be doing something good with your life in those 20 minutes, so I'll shorten it. You are all very welcome. Now when you heat up a precipitate, it dissolves into the solution. With this situation, if you let the solution cool after heating, it will form beautiful gold crystals of lead 2 iodide. Since I added too much, again, it takes a bit longer than expected. Now I'm going to take this time to say that probably after the next few days, I won't be able to post a lot of videos in the upcoming month or two, or probably for the rest of the year because of school. Now I'm going to try to be as faithful as I can to all of my followers and to YouTube and post as often as I can, but some of these experiments take quite a while to set up and organize, so I'm going to try my best with that. Hopefully for September I'll be able to get out maybe 2, 3, or 4 more videos for the month. For October I have an entire list of experiments prepared for Halloween, for our special Halloween segment we're going to be doing, with dry ice, calcium carbide, making fake blood with another double displacement. So I highly recommend you check us out next month, and probably for the remainder of this month. But things will be a bit difficult with school, but I guess you understand that. Oh, and I almost forgot. If you're new to our channel, please subscribe, rate, and comment. I'm always open to suggestions and any ideas that you want me to try out, with the materials I have, of course. But I'm open to any suggestions, and I really look forward to hearing that in the comments below or by some other method. But I'm open to it. And now, just for another quick little disclaimer. When you're done generating the lead iodide and the potassium nitrate for this little double displacement reaction, please do not attempt to even think about throwing this stuff down the drain, because, like I said, all lead compounds are obviously toxic, and that could eventually work its way into the public water system and poison about everybody in my town. So please don't do that at all if you attempt this. Just basically give it to a designated company to help, kind of get rid of it for you. They have special companies that they're the ones that drive those hazmat trucks, and they will basically take it off your hands and dispose of it properly. So, thanks. Now that we're finally done waiting for all of the lead 2 iodide precipitate to finally dissolve into solution and then to finally cool down, we'll be able to see the so-called golden rain. Now, chemists have called the lead 2 iodide crystals golden rain because of its crystalline appearance and how it reflects the sun's rays once it hits upon it, and it starts to really shimmer a bit. And it honestly does look like golden rain. So that's basically our entire experiment in 2 parts in one video. I hope you really enjoyed it. There's not much more I can really say on this experiment because it's more of just seeing than me speaking about it. So you'll be able to get a full glimpse of the true beauty of the crystals. Again, do not touch this with your bare hands because it can eventually be absorbed into your skin, and lead is a very toxic element, and it's really not good to have that in your system. So please do be careful, and I hope you enjoy the next couple, probably a minute or so more, of the images I have here. As you can see in this take here, you'll be able to see all of the crystals cool down at the bottom. This is after the day after I did the experiment. This is the next day when it fully cooled down. So you'll be able to see how much it glimmers, because I did it early in the morning when the sun was finally out, so it looks absolutely beautiful. Now, unfortunately, you can see at the top, at the neck of my Erlenmeyer flask, that a lot of lead iodide precipitate that hasn't been able to dissolve completely has been stuck to the neck of the flask, and that's not very good, so I have to go wash that off as soon as possible. But that's my problem and not yours. So check us back next week for a new experiment, and I hope to see you all there. Have a great day.